Hello, all. This is Dr. Dave Maslach talking about reciprocity.com. The E is spelled the three, where I truly believe you should get all of the feedback, skills, and wonder required to become a prolific writer and scholar. So in this particular video, I really wanted to talk about internal threats to validity, in particular instrumentation. This is part of my Nerd Out Wednesdays series where I talk about things on Wednesdays that I really like and that I find really interesting in science. I'm a professor of innovation strategy and entrepreneurship, and there are a lot of things that happens in science that are truly nerdy, but they're truly fun and interesting concepts to talk about. And there's all sorts of stuff that go on. And one of them is this idea of internal threats to validity. I'm going to get into exactly what that is and what instrumentation is. And then finally, talk about how to mitigate these problems of instrumentation. What are some sort of recommendations to mitigate these problems of instrumentation? So what is internal validity? Well, that is where there are reasons, so threats, there are reasons that you might believe that a study is not making a causal inference. So meaning that the relationship between A and B that you're trying to uncover and trying to discover is kind of muddied, and that there might be other reasons why there is this relationship between A and B. And one of them is instrumentation. Now imagine that you are a scientist, you're somebody that's working in a lab, and you're working doing a lot of lab research, and you're halfway through a study, and the particular instrument that you're using, maybe you're measuring barometric pressure, maybe you're measuring temperature, and you realize that the instrument broke. Well, what can you do when that happens? Should you continue on with the particular research study that you're working? Now, I also want you to imagine that the instrument that you're using, such as a thermometer, is not very accurate. And as you're measuring it and you do repeated sampling of a particular measurement on somebody's body, for example, and you're measuring temperature of somebody's body, you realize that the instrument is not very accurate and there's actually a lot of variance with the particular thermometer that you have. Now, these stories are actually real, true things that happen. In fact, measuring your body temperature, 98.6, is not... Most people's body temperature sort of varies around, somewhere around there. It's not always 98.6. And the instrumentation, the original instrumentation to use that to get that judgment of 98.6 years and years ago when we discovered that wasn't accurate, in that the instrumentation, in fact, all the old instrumentation from years and years and years ago, just like in the future, they're going to say, all of that instrumentation was highly inaccurate. It's very, very, every time that you used it, it actually would not be a very accurate measurement, right? Just like anything you do now, it's going to get better. The instruments that you're going to have are going to get better over time. So should you throw out the study results based on, maybe something broke, maybe that the instruments that you're using are not accurate, they're continuously changing? Now, this is stuff that we have to deal with as a scientist all the time, as a researcher all the time, whether you have to throw something out. And that particular issue is what the threat to internal validity, the instrumentation threat to internal validity, is getting at. So this is essentially, you want your instrument to be consistent, the way that you're measuring something to be consistent all the way through the thing that you're studying, what you're looking at. But often that doesn't happen, right? And sometimes you have to throw out a study because the instrument was so highly inaccurate you couldn't get a good measurement. Or maybe it broke and you can't get the similar sort of reading again. But often you don't have to do that. In fact, there are all sorts of statistical techniques where you're trying to uncover measurement, what's called measurement error, when you're doing that. And you can do like a structural equation model and try to capture the measurement error. In fact, regression tries to capture measurement error as much as it possibly can. You can uncover that with one particular technique. It's called the errors and variables technique. and that can get some of that measurement error. You can also do an instrumental variable technique. It's kind of sort of one type of instrumental variable technique, and you can capture it that way. But there's all sorts of ways to mitigate, sort of less sophisticated and complicated ways to mitigate this problem of instrumentation of happening. First of all, if something breaks and you have to get a new instrument, what you can do is just put a control variable in there. In fact, this happens all the time if you're looking at archival data, for example, and you're looking at things that sort of change over time. Often that I find, so I study the medical device industry a lot, and I look at archival data there, is that the FDA will come up with a new way of measuring something. They'll come up with a new ruling, and all of a sudden there'll be a jump, or that there'll be some sort of break in something. In fact, that is often a really useful technique to get at sort of causal understanding if that's the case, because then you can understand, well, what is that break? And then you can look at the difference between before and after that break to see if that instrumentation, that change actually affected something else that you would never have thought about along the way. And so you can get at some really interesting ways of getting at that. Also can sort of strengthen your study as long as you're well aware of that and you're putting in sort of ways. Maybe you can have, there's various different ways to get at this strengthening your study because of instrumentation, particularly if there's problems like that. One way is just not to rely on one particular instrument, not being heavily reliant on sort of complex instruments either, right? Ones that are really difficult to understand and that there's all sorts of moving parts. In the lab, for example, you can imagine a lab, you might have one instrument that costs millions of dollars and is trying to measure something. You want to do sort of the Razor's Law. I'm slipping on the name. But anyways, you want to make sure that you're doing things as simple as possible, right? So if there is an instrument that's simpler and it's just as accurate as something that's really, really complicated, then use that, right? Use that particular instrument. You don't need something that's really complicated. It's actually going to make it better, because then what you can also do is make sure that you have redundant measurements, more redundant instruments that are measuring the same thing. So it's not, so coming back to the lab example, one thing that we know, I'm a chemical engineer. I was trained as a chemical engineer, went into business after that and studied business and organizational theory. But one thing we do know is that the ideal gas law kind of works pretty good. And the ideal gas law essentially just means pressure times volume equals nRT, and T stands for, N is a, N and R are they're sort of constants, but T stands for it stands for temperature. So we do know, okay, coming back, that was a sidetrack, woo. Okay, so we know that pressure, volume, and temperature are all related in a container, right? That's all I'm trying to say. Pressure, volume, and temperature, you can measure those in different ways using different instruments. And by using those different instruments, you can capture that particular effect. And you can get sort of redundant effects, and you can study what's going on a little bit better than if you just use one particular instrument. And that's why we want to measure and use different redundant instruments in case something does break, in case there is a problem, in case you want to get different insight, right? So one cool thing with the ideal gas law, we know that it only fits for one, really, really basic gases at room temperature and all this kind of stuff. In fact, that for most of the world, it doesn't work. For most of sort of real world conditions, it doesn't work. And you have to put in all these different parameters. And what the cool thing is, if you use something like that and you use very simple instrumentation, you can start uncovering all of these sort of conditions and, different sort of factors and different sort of reasons and understandings of why things might work in a different way. So coming back to, again, measuring your body temperature, for example, using that inaccurate instrument for a long time, you can measure it in different ways. But then when you go back and you measure sort of more accurate instrumentation, and you get that accurate instrumentation across multiple individuals, you start seeing that individuals, they don't have the same body temperature, but there might be a degree, somebody's body temperature is consistently 1 degree temperature more than somebody else's, and somebody's body temperature might fluctuate throughout the day on a routine basis compared to other people's. And you can get all sorts of really interesting results by simply looking at that, making sure that you are having redundant measures, making sure that you have redundant instruments to measure a particular thing, simplest instruments as you possibly can. And that's going to mitigate a lot of your problems of, the instrumentation threats to internal validity. And you're going to be able to rule that out as much as you possibly can. Again, with a threat to internal validity, you can never rule it out. It's impossible, right? I mean, you can never get sort of causal understanding, but you can rule out all these different effects as much as you possibly can. Now, if you like this video and you want to learn out more stuff about internal threats to validity, there's a bunch of them there. I went into like regression to the mean. I went into contamination, all sorts of different things put in there. If you like the Nerd Out Wednesday stuff, I do put out things about being a scientist, a researcher, and trying to help you as much as possible, things that I find interesting. And then I also sort of talk about being a writer as well as, just wonderment of the world. So I study innovation, technology, and stuff like that. And there's all sorts of really cool things about how we understand the world, how do we arrive upon, deciding whether something works and becomes, what an innovation is and stuff like that. And, I'm just really curious. I really love it. It's awesome. And I'm building this reciprocity platform as a way, it's an extension to make myself become a better writer and you become a better writer and become amazing. But as well as, doing it as sort of a scientific endeavor, see if I could actually do this, apply some of the stuff that I teach in class and see if it actually works. And I have learned a lot of crazy stuff that I would never have learned along the way without doing this. So check out those videos, appreciate what you're doing, and I'm really looking forward to seeing you on the next video. Bye.